No. Yep. Right. Yep. Yeah, and that allows you to reuse a lot of the mechanicals of existing server systems, right? So I have a server that has, 24 slots for 2.5-inch drives in the front. What if instead of running, SAS or SATA up to those drives, I just ran a bunch of PCI Express and, either switched it or individually had one lanes going out to this, like what these guys are doing. Yeah, that's actually, I think, sort of the beginnings of this sort of, one of the transitions I was talking about before. One of the interesting things, though, is that if you look at the 2.5-inch form factor, it's not exactly ideal for optimally packing NAND devices. Yeah, so even 3.5. Really, for flash, you really want a little more surface area than that. So none of these are ideal, but you can make do. And reusing the mechanicals of the chassis are very beneficial in a lot of ways. Yeah.
You spent quite a great deal on concurrency. Back then now, let's call it one socket, forward.
Yep.
Back to the branching parallel, the building block is the man.
Yep.
Which is beautiful, right? It helps us with the application layer. However, would you say that the data where we're building things with rate controllers is kind of a single point of confluence? The core can address the device, but they have a rate controller in front of the flash.
Right.
That will really limit your concurrency.
Yeah, and it depends on the design of this RAID controller. I mean, one of the things that vendors are working on for their flash controllers, which you can kind of think of as the moral equivalent of today's RAID controllers, meaning I have a bunch of NAND devices behind a thing that sort of coordinates access to them and makes them appear as a single device, is that even those are getting super concurrent. I mean, some of these things have, like 16 cores, individual little embedded CPUs running firmware inside of them. So that right there, again, brings you back up to a lot of concurrency and a lot of, I would add, firmware complexity inside the replacement for the RAID controller. So concurrency is just going everywhere, even in the firmware of these things now. And so, like I say, it is going to be a very interesting thing because, well, as everyone has pointed out, currency is kind of hard. Does that make sense? Any other questions? Right, and that sort of brings you into, if you want to talk to files a little bit differently, well, the POSIX API isn't, I mean, it's the very definition of the POSIX API is that you can't be different. It is kind of what it is for a very good reason. And I think what you'll start to see is you'll see a file system that provides all the stuff that you love about a file system, access control, checking permissions, things like that, namespaces. But a lot of applications, you see this, like I mentioned before, with Hadoop, with Google, with all sorts of application stacks out there, because you don't really need all the nice things that a file system brings along with you. You just need a more simple thing. It's like, I'm going to be working on a bunch of data. I want to address this part of the data with this key, that part of the data with that key. A much simpler interface, where perhaps the expression of concurrency could become a lot simpler and a lot easier. File systems, of course, on the back end can be changed to take advantage of, the increasing parallelism of the underlying storage devices. So as I mentioned before, I think what you'll see is you'll start seeing the metadata, which is really the thing that gets the most abuse and wear and tear, if you will, in a file system, start to move to these newer APIs on the back end, and then just being used in bulk storage. You've seen this in the database market. The migration to this for years is the bulk data moving out of the database, and all you have are little object tags or whatever in the main database itself. And then when you actually want to get the results of a query, you're like, now I have a bunch of objects. Let me go reference and see what the data actually is. That way you keep your database small, very, very fast, potentially on smaller, more performance media, and the bulk data is out there on fundamentally cheaper storage. Does that make sense? Anyone else? All right, that was easy. Thanks.